Hi guys, and welcome back to Drive to School Chat, where we discuss a topic or a subtopic in geography on the way to school. Now, today I'd like us to talk about the UK's seasonal climate and the impact it has on the formation of waves here in the country and also on erosion rates in the country. Now, all this will be done under the umbrella of the UK's evolving physical landscapes, which is topic 4 of the Edexcel B specification. And the first thing that I'd like us to talk about then is the UK's climate. Now, here in the UK, we have what is referred to as a temperate maritime climate. And temperate there refers to moderate. Another word actually that can be used is moderate. And when we are talking about a moderate climate, we are referring to a climate which is not too hot, neither is it too cold. And then when we are talking about maritime, we are talking about a climate that is impacted by the sea, because maritime there is from the word marine, and we know that when we are talking about marine life, for example, we are talking about sea life. So the ocean has an impact on the climate here in the UK. Now, that means then that we have winters that are not too cold and summers that are not too hot. And one of the reasons, the main reason for that really, is the UK's prevailing wind. Now, prevailing wind is the wind that blows most of the time in an area, and also the direction that wind is blowing from. And for the UK, the prevailing wind is the North Atlantic drift. Now, as the name suggests, that prevailing wind is blowing over the Atlantic Ocean. Now, where is it coming from? It's coming from the Gulf of Mexico. Now, if it's coming from the Gulf of Mexico, then that means that it's coming from a warmer part of the world, because the Gulf of Mexico is closer to the equator than we are, which then means that it's going to have a warming effect here in the UK in the winter, because it's going to bring in that warm air from the Gulf of Mexico. And that's why in the UK, the winters are not too cold. For example, this year in the UK, I think we had just one day of snow. But if you go to mainland Europe, they have several days of snow. Okay, and that's because they don't have that effect of the ocean being around them. So here in the UK, we get that prevailing wind, which is from the southwest, and it's called the North Atlantic drift. Okay then. So we need now then to move on to how waves form. Now, as those winds are blowing over the surface of the water, they are actually dragging over the surface of the water, which then implies that there is some friction taking place. So the wind has friction with the sea. And because of that, it's going to cause ripples to begin to form. Now, those ripples are obviously being formed because the wind is pushing along the surface of the water or dragging along that surface of the water. And the shape of the orbit of those waves when it's out there at sea is normally circular. Now, as that wave then approaches the shoreline, it's going to increase, and especially if the winds are quite strong, it will mean that you will have the formation of waves. So not just ripples any longer, but then now you have waves. And the size of the wave is going to be determined by the strength of that wind. Now, as the wave comes towards the shore, we know that the depth of the water is going to decrease. So the seabed is going to become shallower. Now, as the seabed becomes shallower, that means that the bottom part of the wave is going to experience a lot more friction. And that friction is going to cause that bottom part of the wave to slow down significantly compared to the top part of the wave. Now, the top part of the wave is called the crest of the wave. So the crest of the wave will ideally be moving faster than the bottom part of the wave, because this bottom part of the wave is experiencing this friction that is being caused by a shallower seabed, which then means that top part of the wave, or the crest of the wave, will eventually outrun or overrun the bottom part of the wave. And that is a process by which the wave will break. So we normally say that the wave breaks, and the wave will break because the crest of it, or the top part of it, is going to topple over the bottom part of the wave. So that is when the wave breaks. Now, the other thing that we need to mention here that will determine the size of the wave is the fetch. And the fetch refers to the distance that the wind has blown over open water. Now, obviously, if the wind has been blowing for a longer time and over a longer distance, then it's likely to create a lot stronger waves. But if it's been blowing for a shorter distance, and for a shorter distance, then the waves are not likely to be as strong. Okay, now moving on then to the types of waves. The first type of wave that I'd like us to talk about is destructive waves. And before we get on to talking about the features or characteristics of destructive waves, perhaps the best place to start is talking about swash and backwash. Now, swash refers to when water washes up the beach after the wave breaks. So what happens is the wave will break and then the water will be pushed up the beach. And we know that the beach is normally at an angle and it slopes upwards. So material will then be pushed up the beach as the water is washed up. Then we also know that anything that goes up is likely to come back down because of the pull of gravity. And in the same way, the water that washes up the beach is going to wash back down. And the process through which, by which that water is going to wash back is what we are referring to as the backwash. Now, having established that then, destructive waves have a stronger backwash than swash. Now, that means that they will destroy the beach. And just like they are called destructive waves, they actually destroy the beach. Now, the other characteristics, so they have a stronger swash than backwash. That's a first characteristic. Then the second characteristic is that they have a shorter wavelength. And the wavelength is the distance between two waves, or the crest of two waves. Now, when that distance is shorter, that wave is likely to be a lot more powerful, and it's also likely to be a lot higher. And because it's a really high wave, so that's now actually the third characteristic. So the wave height is, well, the wave height is high, if we may use that terminology. So the wave height is high, and the wavelength is short. So that wave height then means that the wave will be really, really high. And in fact, it's called a plunging wave as well, not just destructive waves, they're also called plunging waves. And the reason for that is because is that they will plunge downwards after the wave breaks. Which then means that as they plunge downwards, they are going to have a very massive impact on the beach. So the sand that is on the beach. Now, that sand that is on the beach will be hit by this plunging wave, and as a result of that, the beach material is going to be loosened. Now, because it has been loosened, when the backwash takes place, that beach material, so the sand and the sediment and everything else, is going to be dragged back into the ocean. And because it's being dragged back into the ocean, the beach is actually being destroyed. It's being deprived or depleted now of the sediment or the sand that is on top of it. Now, why is that a problem? That is a problem because the beach is the first line of defense. The beach will actually protect the coastline from erosion because as the waves come in, they are going to, the power of those waves is going to be absorbed partially by that beach. So if the beach is depleted, then the rates of erosion are likely to go up. So destructive waves are not good. And they happen mostly in the winter when we have the strongest winds. All right. Now, what's the other thing we need to mention about destructive waves? Yes, the other thing we need to mention about them is that they cause the beach to be very steep-sided because of that plunge of the wave. When it destroys the beach material or hits it, it then causes the beach to be a lot steeper and narrower. So a shorter beach, and it's also steeper, which then means that any cliffs that are behind that beach are likely to be now exposed to erosion. And because we know that the winter seasons will last obviously for a significant length of time, that beach will, or the cliff behind the beach will be left exposed for quite a while. And if the process of those strong winds coming in and those strong waves coming in keeps on repeating itself, then there'll be a lot of depletion taking place. So for example, Holderness is a coastline in the northeastern part of the country, and the erosion rates there are around 2 meters every year. But when we get very strong waves in the winter, sometimes those erosion rates are going to be a lot higher. And sometimes you could actually have that 2 meters being eroded sometimes even in a day. Okay, so that's the impact of destructive waves. All right then. Now let's move on then to constructive waves. Now constructive waves, as the name suggests, are going to build up the beach. What are the characteristics? So the first characteristic is that they have a stronger swash than backwash, which means that as they wash up the beach, they are going to push up the water and the sediment they are carrying up onto the beach. And then they have a weaker backwash, which means that that material that has been pushed up the beach is going to get sufficient time to settle on the beach other than be washed down the beach by the backwash. And in fact, one of the other reasons why the backwash is weaker is because some of the water that has come in as swash will percolate back into the sand because there is no plunging like we had in the destructive waves. So there's no impact. It's just water washing up. So as it washes up, some of the water will sink into the sand or infiltrate the sand. So the amount of water that is going to be coming back as backwash is reduced, and therefore the backwash will be weaker, and therefore that will build up the beach. Now, the other characteristic here that we need to mention where constructive waves are concerned is that they have a longer wavelength. And because they have a longer wavelength, the third characteristic is that they are also a lot lower. So they are not that high. They are a lot lower. All right. So that there then is the constructive waves. And the constructive waves are also known as spilling waves. We said that destructive waves are known as plunging waves, but constructive waves are known as spilling waves. All right then. Now, the last thing that I think we need to mention here is the impact of climate change. Now, we know that climate change is a global phenomenon, and it's leading to rising sea levels, thermal expansion, which then leads now to bigger storms at sea, which will also then imply stronger waves. So for the UK, it means that having bigger waves, there will be potential for a lot more erosion in the future if climate change continues to impact on the planet as much as it has been in the recent past. So if something is not done to address the issue of climate change, then that is likely to be an issue that places like the UK are likely to need to address, because bigger storms, bigger waves would then imply a lot more erosion on the UK coastlines. All right, let's do a quick recap then. What have we talked about? We've talked about the UK's climate, and we've said that it's a moderate or temperate maritime climate. And then we've also talked about the seasonality of that climate, that we have obviously the winter season and the summer. Those are the ones that are important when talking about coastal erosion, because in the summer we get weaker waves, and those weaker waves are constructive waves which build up the beach. And then in the winter, we get the plunging waves or destructive waves due to stronger winds, which then destroy the beach or cause a lot more erosion. And then lastly, we've talked about climate change and how it's likely to impact on erosion rates as we go into the future. All right then. Thank you very much for joining me on this Drive to School chat and on this journey towards excellent exam results. If there is a topic that you'd like us to cover on the way to school, please do let me know in the comment section below, and we shall be sure to discuss it one of these fine mornings on our way to school. All the best, and see you again soon. Bye-bye.